Hi everyone. Our lesson today, we're going to talk a little bit about our last thing. We start a new thing today, which is talk about arc length and measures. Great. I hope we together go through this thing here, which is supposed to be simple, easy. But to start our lesson, pick our book, page 617. Okay. Okay. I hope you pause the video, pick your book, come back, page 617. Great. The key terms we're talking today is arc length and radian. And we're talking about use arc length to determine circumference of circle, solve problems use arc length measurements, and use similarity to show that an arc length of a circle is proportional to the radius. Pause the video and solve these guys here. Okay, great. I hope you did already. Measure of angle BD is the supplement of angle BC, which is 120. What is missing to be 180. Measure of angle D is vertical angle. Measure of CD is half circle, and the circumference. I think you remember the formula, 7th graders. I think you remember that. It is 2 times pi times radius. Our radius is 4. 2 times 4, 8 pi. Great. Let's go through. We just skip some pages, okay, guys, because this first one is how we get the formula. I think everybody's fine. And this second one is just to prove all circles are similar. I think you did already this in the past. If you're not sure about that, you can do it now. It's up to you, okay? But to use a lot of proofs over things here, which I don't want to go through this point of the school year right now with you. We are all tired. Let's focus on exactly the lesson, which is go to page 622. We just measure comparing things here, application, okay? The page I want you to go is 622. We have two gears. They're connected with each other, but they have the same angle here. Go through question 1 and 2. I'll give pause the video. 5 minutes, I think you go through this thing here. Okay, I hope everyone finished this thing here. The first question is describe the relationship between the length. And as we see, all circles are similar. Then the gears are also similar. Great. That's it. Determine the degree measure of the minor arc in each circle. The minor arc, 60 degrees. What is the ratio of the degree measure between all full circle? Oh, the angle we got is 60 degrees. Full circle, 360. Simplify the fraction, 1/6. Great. And here, number 2 is a problem. Okay, so the two minus arcs AB and FG are equal, same measure, which is 60 degrees. So the two arcs are the same length. They have the same length, guys. No, not the same length, because they have different radius. Okay, as the radii is different, then the arc length also is different. Then the minor arcs AB and FG have the same central angle. Yes, we agree with that. But the circle has a greater, one circle is greater than other one diameter. Okay, that's it. Next page, we're talking about arc length. In a circle, the degree measure of an arc is equal to the measure of the central angle, arc length. It's a linear measurement that represents a portion of circle. Go to question 3, 4, and 5, and 6. Pause the video right now. Great. I think everybody's back here. Question 3. If the length of the radius of the circle large gear is equal to 4 centimeters, determine the circumference. Circumference formula, 2 times pi times radius. 2 radius is 4, 2 times 4, 8 pi. Use the circumference determining question 8, which is 8 pi, to determine the portion of the minor arc. The portion is 60 divided by 360, which is times 1/6, because we simplified the formula before. Great. What is the new fraction here? 4/3 pi. The smaller gear, 2 centimeters. What is the radius? 2 times pi times radius, 2 times 2, 4 pi. And part of this is 60 degrees, 1/6 again, 4 pi times 1/6, which is 2/3 pi centimeters. Okay, go through here, page 624. It explains how we calculate arc length. Arc length circumference is central angle measured divided by 360 times the circumference, which is the formula we know already. Great. And radius of distance here to calculate is arc length divided by circumference equals central angle measured divided by 360. Great. If I gave you the angle or the arc length, and we know the formula, and we're looking for the angle, we can calculate also. Great. Go to question 7 and 8. I'll give you a few minutes. Great. I'll just write the answer over here, guys. Number 1 here is 2 pi inches. And B, it is 2 pi radius. 2 pi radius units. Question 8. The constant of proportionality is pi divided by 180 degrees, which this is the thing about radian. Okay, radian, it is 1 pi equals 180 degree. Yeah, this is very nice. Okay, that's why they started talking about radian. Give a few minutes, go to the question 9 here, next page 625. Okay, I hope you did already. The first one, you will calculate, it is 80 divided by 9 pi. The second one, it is 40 divided by 3 pi. The third one, 20 divided by 3 pi. Great. D here, compare the worked example, part A, just compare part B and C to specify why this relationship exists. What do you notice here? Well, we can notice when the radius doubles, what's happened here? Like we go the radius 20, 10 to 20 or something. What's happening here? Because it was 20 and 10 inches, B and C. Well, we notice when the radius doubles, the angle remains the same. Then the length of the arc. Doubling the radius also doubles the circumference. So the corresponding portion of the circle represented by the arc also doubles. If you notice here, 20 because it's 10 inches and 40 because we double 10 inch to 20 inch. Okay? That's why. Guys, question 10 and 11 is only applications. You can go through this thing here. If you did this one here, you will notice it is 40. Okay, first we calculate everything. 40 plus 8 pi. Great. And 11, how does the arc, sorry, how does the arc length, A first, the arc length of the minor arc is the larger in 10 times the other one. The arc length of the minor arc in the large tree ring is 30 inches. B. And the third one, if the measure of angle is 20 degrees, the circumference of the large circle is 30 times 18 equals 540 inches. Okay. We go through here activity 3 quickly. It's just applications. Create the radius of smaller wheel, 3 centimeters, larger wheel 5, and the center of the wheels are 14 centimeters apart. And describe the 4 sections that Alejandra noticed. Okay, the first one is the arc along the smaller wheel, which is this guy here. This is the arc. The arc along the larger wheel, this guy here. And the 2 tangent segments. Tangent segments is C to D and E to F. If we draw here the things, you just draw what you notice. And what do you notice about this? We have a quadrilateral in each section. We have a quadrilateral here on bottom side section and the quadrilateral on the top section. Great. And what also we notice here? Which kind of quadrilateral is that? Remember to classify here, question 3. Classify quadrilateral. And classify triangle ABG. ABG here, AB. And go through G. Which kind of angle is that? Great. Here, where is angle G? Let me show to you here. Where's the point G? The point G, when you create the points here, you see 90 degree here. Oops, supposed to be 90 degree here. I bet. Oops. Great. Nice. This one 4 number we can skip, no problem. Number 5, we just label the sections. I will just skip this point here. We're not calculating this guy here. Okay. And activity number 4, we're calculating radians. Okay. To calculate 1 radian is the measure of a central angle whose arc length is the same as the radius of the circle. The radian measure theta of a central angle is the ratio. Next page. Okay, guys. Sorry, my bad. Page 629. The radian measure angle theta of a central angle is the ratio of the length of the intercept arc to the radius of circle, which is the section divided by radius. Great. Or this section is the theta times radius. Let me show to you some example here. If you go here, we can create a relationship. A full circle. Remember, as I told you guys, pi divided by 180 degrees. That's the relationship. Okay. And we just write here the angle we have, which is theta divided by, depends how many degrees you're talking about the thing. Okay. Usually is, oh, this is my bad. Here, pi divided by 60, pi divided by pi divided by 180. That's better. Let's go through this thing here. What is the radian measure of this entire circle? Well, if one it is 180, how much will be 360? Then it's 360, and we put this x here. We just cross multiply here and here will be 360 pi equals 180 x divided by 180 both sides will be 2 pi. Wait, if we label our circle here, Here is pi divided by 2 because of a half of 180 degrees. Pi. Here is 3 pi divided by 2 and 2 pi. Great. And if you can measure here, 1 degree in radius, just do the same formula we did before. You got a 0.017 radian. And 1 degrees in 1 radian, it is 57.3 degrees. 1 radian. Okay? We have some worked example over here. We're not going through all everything. It's up to you. If you have time in the class, just go through. And we finished this lesson today, guys, with the homework, which is in page 633. You will see this in Google Classroom, okay? 633, 634. Okay, we're about to finish the year, guys. This is the last thing, one of the last things we're going through. We explore algebra and geometry. We calculate areas and volumes right now in circles. And let's explore this better, okay? That's it, the lesson today, guys. Have a great day. Bye-bye.